most of these are going to be the same that you already know. If you take a quick look, like two numbers that have a difference of 6, product is a minimum, right? So these types of problems we've seen before. Daily profit, that's just straightforward. Just find the derivative, set it equal to 0. See what's the maximum or minimum that you're looking for. Two positive numbers, again, product 64. So a lot of these you can do already with everything you know. But you will notice there are 3 problems that have something to do with a cylinder or a drum, which is the shape of a cylinder. So like number 7, and then back on the front, number 2 is talking about a cylinder, and the example is a cylinder as well. So only 2 of them will be based on this problem I'm about to show you, which follows the same exact process that we've been doing, but just has a little bit more work involved. Okay, so rest assured you have most of what you already need. So looking at this, it says we got an open barrel that has a surface area of 3 pi square feet. And what is the height? Radius that will maximize the volume. So we still have our 2 formulas. One of them is surface area, right? And we have to know and figure out what the surface area of an open cylinder is. So, of course, that's going to be the area of the bottom, all right, plus the lateral or side. Lateral slash, that means the side of it. Okay. So what is the area of the bottom? Well, that's just a plain old circle, so we know the area of that is pi r squared. Okay. And what is the area of the side, just the side of a cylinder? So that's going to be, right, if we take this a cylinder like label around a can of soup, something like that, it does come out to be just a rectangle if you unfold it all the way. So the area of the side of a cylinder is really just the area of a rectangle. Goes a little bit, right? This has a height of h, so that's height of h. The question is, after you unwrap it around the circle, what is the length from here to here? What is the length or base of that label? Right? So since this wraps all the way around the circle, the length of this is just the distance around a circle, also known as the circumference. Right? So we know that this length right here is just the circumference of the circle, so the label would wrap all the way around it. That would be 2 pi r. So the lateral side will be base times height. So we get 2 pi r times the height. So, and this is really what's the difference, is that we have to construct this formula. There's not a set formula really. You know, you might have to put it together depending on what the conditions of the problem are, like it's open and things like that. But if you come across another problem that has an open cylinder and it's talks about surface area, it'll be exactly this. You could reuse it. All right, so we are given the information here that this is equal to 3 pi square feet. All right, so I can put that in and we can start getting our equation together. So the thing that's really different compared to what we've already done is that this part is taking a little bit longer, right? It's not just a simple formula that we had to solve for a variable. We actually had to construct the formula first, then solve for the variable. Okay, now we're going over here to maximize volumes, or the formula that we're actually optimizing, right? Finding the min and max of is volume. So we have that other formula, right? Volume, which is just length times width times height, right? Now, length times width times height, well, that works for like a regular volume, where this is the base and it's rectangular. For a cylinder, instead, it's pi r squared. It's the area of the base times the height. Okay. So we are going to plug in a variable. So we have r's and h's here, and we have r's and h's here. So you have to do a critical thinking moment and ask yourself, which variable do you want to solve for? Technically, you could go either way. We could solve this equation for r, get r equals, plug it in for here, or we could solve this equation for h and plug it in right here. So, of course, you want to take the one path of least resistance, the one that would be easier, less work. So, in all your infinite knowledge, which one do you think would be the best choice? What's the best path to go down here? And this is really the hardest part of the problem, is making this decision. So if I ask you to solve this equation for r, and then I ask you to solve it for h, which one do you think would be easier to solve for? Which one would be less messy? R or h? And then if you're plugging something into this equation, which one would be easier to work with? If you plugged it into r and squared it, or you just plugged it into h? Give you a second to think about it. Anybody have any ideas? Which way to go and why? It's a thinking person's problem, for sure. Well, do some what ifs in your mind. So if I gave you like r equals, it's r squared minus, oh, it wouldn't be r squared, but it'd be like 2 pi h over h minus 1 or something like that. If I said this is what r equals, would that be really nice to plug into here? And then you'd have to go through and square it and everything. Would that be pretty good? Or would it be better to have something like h equals like 4 minus r over, 3r, and just plug that into right here? Which one would be easier to work with? I'll wait as long as it takes. Yeah. H, you think would be easier for h, and why? Yeah, basically this has a r to the second. If I plug something in for r, then I have more work to do. If I just plug things for h, I'm ready to go. So, yeah, just that piece alone makes a big difference if you're trying to, keep the path as clean as possible. So we have to make that decision from early on of which variable to solve for. In this case, h is a lot easier. So that lets us know how to complete the rest of the problem. I'm going to solve this for h. I'm going to plug h into here. It's going to be equation strictly with r's. Take the derivative, set it equal to 0, and do the same steps we've already done. And that's really just the new part that we have to look at today. So let's go through here and solve this for, let's see here, solve this for h. So I need to move this over. So I'll subtract the pi r squared both sides. I'll have 3 pi minus pi r squared. You'll notice that these problems have a lot more symbols floating around, so the neatness of your writing makes a difference. If you try to skip any step, it can get kind of ugly. I'm going to keep putting this in red so we are reminded of what we're actually solving for. So if I need to get h by itself, I need to divide the 2 pi r, right? So those cancel out. So I'll have h only. So of course I have to do that to both sides. Alright, so now I have h equals, and if this could be simplified, definitely always simplify as much as possible. The fact that there's a pi in every single term lets me know that I could probably cancel that out. So let's factor a pi out from the top. I'll leave me with pi times the quantity of whatever's left over. In this case it'd be a 3, and then a negative r squared. And I'm going to remove the pi from the 2 pi r. I'm just going to write it in front. So I still have 2 pi r on the bottom here, right? But I just put this out here so I can clearly see that they cancel out. So I have my h. My h is now going to be 3 minus r squared over 2r. So I'm going to drop that right in there and simplify again as much as possible, right? Before we take the derivative. So we have v is going to be pi r squared. That's the area of the circle on the bottom. And now we know the height to be 3 minus r squared all over 2r. And we need to get this ready for to take the derivative, right? So we need to get this in that format. This is not quite, ready. We can't use the power rule when it looks like this. So let's simplify a little bit until we get there. So I see an r on the bottom here. That can cancel out with one of these r's. So let's say that r cancels out, leaves me with just 1, and this r will cancel out completely. And I need to get all these to be a single term, so I have to distribute the pi and the r back and multiply that by 3, and the pi and r multiply that by the r squared. So quite a bit of little work I have to do here. And I'm going to write it in the proper order. I want the coefficient first, so I'd want to write 3 pi r. I'm doing pi r times 3, write that as 3 pi r. Pi r times r squared is going to be minus pi r to the third. So this is a 1, this is a 2, add them up, get 3. And this is all over 2. Okay. And yet still, we cannot take the derivative in this format. We need to distribute the 2 to both terms. Distributive property. So let's make this 3 over 2 pi r. Right, just writing the 2 right underneath the 3. And then over here, there's no coefficient in front of the pi here, so just use 1. So we have minus 1/2 pi r to the third. Okay? And now, finally, we have a format that we can actually take the derivative of. Right? So we're taking it with respect to r, right? Which means you treat everything else just like a regular number. So these pi's here don't do anything different. It's just another number. There's no special thing that happens when they're involved in derivatives, right? Just treat it like anything else. So my derivative will be just 3 over 2 pi. R drops off, of course. And then I'll do 3 times the negative 1/2, just to give me negative 3/2. Pi r to the second. Drop it down by 1 degree. Okay. Kind of squeeze this in over here. So now I can finally set this equal to 0 and solve. And it's nice, you probably notice right away, both of these have a 3 over 2 pi, right? That makes things really convenient, because we can just factor out 3 over 2 pi, and really quickly we're left with something that's solvable pretty quickly. So getting those extra numbers out of the way, I just need to set 1 minus r squared to 0, right? So squeeze it in here. So we got 1 minus r squared equals 0, which of course means 1 is equal to r squared, which means r has to equal 1. Normally it'd be plus or minus 1, but there's no such thing as a negative radius, so we just stick with the positive 1 only. So that gives me my first value over here that to get the maximum volume, this radius is just going to equal 1. Of course, I need to know what the height is, so kind of like a system of equations, I just take this, plug it back into that formula from the very beginning. So we have 3 minus 1 squared over 2 times 1. 3 minus 1 would be 2. 2 times 1 would be 2. So that's 2 over 2, which equals 1. So turns out that to get the maximum volume, both the radius and the height will come out to equal 1. So overall, right, same process, same, structure as all the other problems. It was just a lot more work to get these things set up, a little bit more symbols and moving things around for solving. So it's really going to hit on your algebra skills and pre-algebra skills like distributive property and things like that. And some are not aware of this, like this is the distributive property. If you're dividing a whole fraction that has multiple terms on top, you have to divide every single term by whatever's on the bottom, right? Not just one of them, but everything, just like the distributive property. If you want to think about it as this multiplied by 1/2, it's the same thing, right? So it works both ways. But that's an important detail that you need to know. Okay? All right. So with that being said, let's look at, to get you set up on number 2. We'll just get this set up and then you guys can work on it. Because it's same but slightly different. So we have to make slight adjustments. So a rectangular sheet of paper. Okay. And it's rolled into a cylinder, so it's very similar to what we just did. Right, so 2 pi r is the length, and the height is still h. So what is the perimeter of this? Again, you have to put together the formula on your own and using some geometry here. All right, so the perimeter would be what? And this is the thinking part. It's not a trick question. But you have to think about it a little bit, right? So you tell me, what is it? What is it? 2h, because there's an h here, there's an h here, and then 4 pi r, because there's 2 pi r here, and there's 2 pi r here. And we're told that this is perimeter is 36 centimeters. So I can replace my perimeter with 36 centimeters. All right, and we know the volume already is what, pi r squared times h. So what variable this time do you think you want to solve for? Probably still stick with h, right? Because the r is still being squared for the same reason from the first time, right? So will that change eventually? Probably not for this formula, but other formulas maybe so. So just something to think about. Okay. So that gets you going. You can see that if we go off of what we learned here, and like this is, we already know like how to find the lateral area of a cylinder. We just got to grab this and repeat it, right? But then we had to adjust it from area, from this formula, which was lateral side, surface area, to making sure we use perimeter, right? So it's not a copy and paste carbon copy. Just because it's a cylinder, you have to adjust them depending on what's being asked. And I believe on the last problem, the number 7, they actually give you the volume and ask you to minimize the surface area. So it's really the reverse of number 1, where they give you surface area and tell us to maximize volume. So you'll start with this formula, the volume, solve for a variable, probably h, and plug that into the surface area equation. So you go in the other direction. Right? So all related, but slightly different. Okay? And like we already said earlier, a lot of the rest of these are just two numbers that are this, that multiply to that. Right? These are all just review problems that we already know how to do. 3 is similar to some of them on the first homework, where they just give you the formula, the function already. There's no two equations. There's no parameter or conditional equation. You just take the derivative of it, set it equal to 0, find that maximum daily profit. Okay? All right. So that's all you guys need to know. And you want to try to get this done on Friday, if not by Monday. Okay?